So since the section 1.3 is due next Monday, so I will give you another video for 1.3 as well. Now, section 1.3 actually is pretty simple. If you pass the Math 105 before, section 1.3 actually it is complex numbers. Make it bigger, then you can see it better. So complex number, why do we need to learn complex numbers? Let me turn off this light. Is it better? Okay, so why do we need to learn the complex numbers? When we solve x squared minus 1 equals 0, then we have x squared equals 1, then we have x equals plus or minus 1. Now the problem is, what if we want to solve x squared plus 1 equals 0? Then you get what? X squared equals negative 1. Think about it. If you have 1 squared is positive 1, negative 1 squared is positive 1. You never see any real number, no matter if it's a positive or negative. The square of that number is always positive. But now I have a square which is negative. So how am I going to solve it? The mathematicians are always very crazy. So they stay at home, they imagine, they say, oh, let's imagine something happened. Well, they imagine if a number comes out. They say, okay, let's just imagine that there's one number, square gives you negative 1, then the first letter of the imaginary number is I. Okay, so they define that there's an imaginary number is not real, not exist. Okay, so imaginary number I squared equals negative 1. So now you have x equals positive and negative I. So I is an imaginary number. That's why we have the complex numbers. Let's look at our work. Okay. So first one. Square root of negative 36. Well, I want to skip that actually. This is not a real number for sure. So now this is negative, no real complex. No, we don't do that. Complex number, not real number, pure imaginary number, because this equals 6i, yes. Wait. Non-real complex. Not sure what it was mean of non-real complex. This is for sure is a complex number. It's going to be pure imaginary number. Non-real complex number. Okay, it's we don't really use this a lot. Okay, so it is. So now square root of negative 175. Let me put it back here. Square root of negative 175. You see there's a square root of a negative number. Okay, the problem is the negative. Square root of negative 1 equals I. Okay, so you can just take out the next square root of take the negative out. So you got square root of 175 I. Okay. So square root of 175. 175 is a complex, it's a compound number. You can continue to simplify that a little bit more, and you can simplify that. Divided by 25 is, let me see, 175 divided by 5 is 3 is 15, 35. Okay. So it's 25 times 7i. So how do you do that? You basically just break it down that into 5 and it's 35. Then you can do that is 5 and 7. So you have a 5 square, which is 25. You can square root of 25 is 5. It's going to be out of the square root. So it's 5 square root of 7i. Okay. So it's 5. There should be some place you can type in square. So square root of 7, and you do I, and then check the answer. That's right. Okay. So I'll leave rest of this one to yourself. Leave this one to yourself. It's pretty simple. This one, you can take the negative out, is the square root of 12i divided by square root of 3i, which is square root of 4i, which is 2i. Okay, so next question. I really don't think I need help. Give you help on this one. It's pretty simple actually. Is negative 10 plus square root of negative 40i over 2. Wait a moment. There's no I here. So now the problem is a square root of negative sign. A square root of negative is a I, so it's going to be negative 10 plus square root of 40i, okay, over 2. And then you can simplify the negative 10 divided by 2 is negative 5 plus square root of 40i over 2. Then you can simplify that square root of 40, which is 4 times 2. So it's negative 5 plus square root of 4 times 10 I over 2. Square root of 4 is 2, can cancel with the 2, so the final answer is negative 5 plus square root of 10i. I'm not happy anymore. That's the right answer. This is the same thing as the previous one, very similar one. Okay, so just one more help on this one. It's plus minus is combined like terms. Just regularly, you can treat the I as a variable. For example, 8 plus 7i minus negative 1 minus I. So you can just treat that as a usually normal any variable. So it's 8 plus 7i minus 1 minus is plus, minus is plus I. You're going to have 8 plus 1 is 9 plus 8i. Combine like terms. 9 plus 8i. Okay, see. Right, this is the FOIL out. Probably I should not just do this one. You can do anything. Okay, 4 minus 4i times 9 plus I. So this one you just do for your FOIL, front, outside, inside, last. So 4 times 9, 36. 4 times I, 4i. Negative 4 times 9, negative 36i. Negative 4i times I is minus 4i squared. And you know that I squared equals negative 1. So basically you have 36 plus 4 minus 36 and minus 32i. Minus 4 times negative 1, because I squared equals negative 1. And negative positive, so it's 36 plus 4, which is 40 minus 32i. Okay? Okay, this is the same thing, just FOIL it out. FOIL it out. FOIL it out. FOIL it. Okay. FOIL it. Okay. Divide it. So divide actually is just one more step besides the multiplication. So there's 7 plus 9i over 7 plus 3i. 7 plus 9i over 7 plus 3i. You want to get rid of the complex number in the denominator. We want to rationalize it. So we multiply by its conjugate. The conjugate is always 7. If it's plus, you change it to minus. If it's a minus, you change it to plus. So what do we do? When you multiply the top and the bottom with the same factor. Okay. So for this one is 7 plus 3i. You multiply by its conjugate is 7 minus 3i. The top is 7 plus 9i multiplied by the same number. If you multiply by 7 minus 3i here, you have to do the same thing on the top. Otherwise, it's not fair to the top, right? So 7 minus 3i, so it's 7 minus 3i here as well. Now what you need to do is just FOIL both top and bottom, the top and the bottom. So this one 40 out is 49. 7 times 3 negative 21. 3 times 7 positive 21 cancel it out. Plus minus is minus. 3 times 3 is 9, so it's plus 9. Okay, even this is negative, but I squared is negative, so it gives you a positive. Okay, the middle two 21 cancel out. Then this one 7 times 7 is 49. 7 times negative 21, negative 21i. 7 times 9 is 63i. 3 times 6, 27 is negative 27, but it's I squared, so it's plus 27. So the final answer is going to be 58. 49 plus that is 65. No, 76. Plus this one minus this one is 42i. Oh, we reduce everything by 2, so it's 29. Reduce this by 2 is 38. Reduce this by 2 is 21. Okay. So it says a plus bi. So it's going to be 38 over 29 plus 21 over 29i. Okay. So the same thing, follow the same example, the previous one. Multiply this one by, conjugate is negative 7i. Okay. You multiply the top and the bottom by negative 7i. So the top is negative 21i. The bottom is going to be 7 times 7 is 49. But it can reduce it by 3, so it's going to be 3 again. And the bottom is 7 again. Okay. So this one, E equals IZ. 3 quantities, E equals IZ, give you I, give you E, you find a Z. Z equals E over I. It's the same idea. Let me see, I need to shift this. Oh, do it here. So you have E equals IZ, E equals IZ. Then you got, what did it ask for? Z equals E over I divided by I. E is given 8 plus 3i. I is 8 minus 2i. Okay, then you continue working on this, follow the same step, multiply the top and the bottom both by the conjugate, which is 8 plus 2i. And this one is also 8 plus 2i, the conjugate. Then the bottom doesn't have any complex number anymore. So 8 times 8 is 64, plus 4 is 68. The top you FOIL it, 64 plus 16i plus 24i minus 6. Okay, then you simplify that. Number 18, I to power 24. So, I to power 24, let's look at one thing. So, I to first power is I squared equals negative 1, we know that. I cubed equals negative, I squared times another I is negative I. I to power 4 is I squared times I squared, so it's I squared times I squared, which is negative 1 times negative 1, which is positive 1. Okay, I to power 5, you can change it to I to power 4 times I again. We know I to power 4 is 1, so it's I. So you know there is a period here. The period is 4. Every fourth power, the power, every fourth power you get, it goes to 1. So here I to power 24, I to power 24 actually equals I to power 4 to power 6. Because I to power 4 is what? Is 1. So it's 1 to power 6 is 1. So now you may ask me a question, how about I to power 99? How about this one? If it's I to power 99, you see you can change that into I to the power 96 multiplied by I cube. You probably ask me, why do I change it to I to the 96? Because I to the 96 divided by 4. So this is I to the power 4 to 24 multiplied by negative 1. Negative I. I cube is negative I. And then it is negative I. Okay. So basically, you just use the power divided by 4. 99 divided by 4 is 2, is 8, is 19, is 2, is 4, is 16. You look at the remainder. Okay? You use that power, divide by 4, the remainder. Whatever it is, it goes to there. For example, even I ask you, what about I 2001? Well, you just need to use 2001 divided by 4. So this is 500. It's going to be 2000. And then remainder is 1. So it goes back to here. So equals I. Okay. This is a 1. If the remainder is 2, is negative 2, negative 1. Remainder is 3, is negative I. Remainder is 4, is 1. Okay, so this one, you can do I to positive, I to negative 17. So now, well, you probably ask me, how about negative? It's okay. I to negative 17, you can do 1 over I to the power 17. Well, I to the power 17 is 17 divided by 4. The remaining is 1, so it's just I over 1. 1 over I. 1 over I, you know, 1 is negative I squared. Because I squared equals negative 1, the negative I squared equals 1. Okay? So you can use that. Negative I squared equals 1. You can change that to negative I squared. I cancel out. You have negative I. Or you can multiply both of this one by I, this one by I. You can do that as well. Like do denominator, do conjugate. It's the same idea. It's negative I. Okay, last question. I'll leave this one to you. Is 1 over I to negative 21. You know that. Wait, is 1 over? Okay, so is 1 over that. You know it's going to be I to positive 21. Because 1 divided by that is negative power again. Okay, so basically is this equals, you know that x to the power negative 3 equals 1 over negative x to positive 3, right? Then you have a negative power in the bottom, actually flip it over, so it's going to be I to positive 21. You shift it. I think your teacher probably told you before. If it's down, it's negative. You put it up, it's positive. So it's going to be, you put it up, and you have 1 in the bottom, so multiplied by 1, which is just I to positive 21. Divided by 4, remaining is 1, so it's just I. Right, that's all for the complex numbers. Okay, so